Hi, and welcome to a lightning talk about FlatGeobuf. My name is Björn, and I'm a Swedish programmer and have been into spatial stuff for a long time. A few years ago, I created FlatGeobuf. So, what is FlatGeobuf? It is a fast binary format for spatial data and attributes. It's lossless and with similar flexibility as GeoJSON. Initially, my idea was to make a format similar to the shapefile, but faster and without the limitations. So, why did I make FlatGeobuf? I think it was initially due to that I wanted to know how Mapbox vector tiles work. As you might know, they're based on something called protobuf, which is from Google. I like to think about that thing as a kind of XML, but for binary. I was also triggered by that the best format out there for some use cases was still the shapefile. Then I found a project called FlatBuffers, which is also from Google, and it's like protobuf but faster. I also found FlatBush, a tiny and nice implementation of the R3 spatial index by Vladimir Agafonkin, who you might know as the creator of Leaflet. So FlatBush helped me understand how R3s work, which is something I had wanted to learn about for some time. And to create a format to beat the shapefile, you really need an efficient spatial index to support making spatial filtered queries against the data. So around September 2018, I made the initial commits to implement what became FlatGeobuf. It went through several iterations, also at the spec level, and finally in January 2020, I was happy enough with it to consider it more or less done. I implemented support in GDAL, and it was released in GDAL 3.1 in May 2020. That was an important stepping stone for FlatGeobuf to make it available, for example, in QGIS. FlatGeobuf is also available as a plugin in GeoServer, so you can use it as a data source or as a WFS output format. So I haven't mentioned Cloud-Native. Well, that is because I didn't consider Cloud-Native when I made FlatGeobuf, but it turns out it's pretty much Cloud-Native, but perhaps by accident. A design goal of the final spec was to make the format I/O efficient. That was to support streaming and piping, and that also makes it works well in Cloud-Native. Okay, so a quick demonstration of an example that is also on the FlatGeobuf webpage. And so what happens here when I pan-rate the map is that the browser makes range requests just for the data within the bounding box. Okay, so to sum up the use cases that I have in mind for FlatGeobuf is to use it as a drop-in replacement for the shapefile, GeoJSON or GML. But you could also use it as a system-to-system communication protocol or as an output format for WFS or OGC API.